Hey everyone, Mr. Fritz here. In this video, we're going to talk about the ambiguous case, and it's involving triangles with the angle side-side configuration. So we're going to actually revisit the law of sines and find out that sometimes it's really unclear what the actual real angle and side configuration is of a certain triangle. So let's kind of dive into it. Before you go any further, if you've not already done the GeoGebra activity, please pause the video, go to this link. The link is also in the comments. The link is also on your worksheet. There's plenty of places to find the link for these 4 triangle cases. So please go ahead and do those, pause the video, and then come back to this when you've finished all 4 of those. Before moving on, using the GeoGebra activity that you've now just created or accomplished, finished, once you complete each worksheet, I want you to actually make a sketch of the triangles that you're able to make. So what you should have found is that there are certain kinds of triangles that you can make with each of those configurations. Draw a picture of what they look like before we go on any further. In the first case of the GeoGebra activity, you should have been able to make 2 triangles. Here, C1 is obtuse in one configuration, and C2 is acute in another configuration. So they both have in common that they have the same angle, same side in that order, but we found there's 2 different ways that you can make a triangle work with those conditions. And actually, I want to take a look at the C2, the acute angle first. Let's see if we can't find what C2 is, and let's use the law of sines to figure that out. And hopefully you're seeing here that I've got an angle and an opposite side, an angle and an opposite side. That's when I want to use the law of sines. So the sine of C2 is going to equal, or rather the sine of C2 over 10 is going to equal the sine of 30 over 6. If I solve this for sine of C2, I get sine of C2 equals 10 sine of 30 all over 6. And once I punch that in my calculator, the sine of C2 is going to equal 5/6. So if I take the inverse sine of both sides, this becomes C2, that angle C2, is going to equal the inverse sine or the arc sine of 5/6. Punching that into my calculator, I get C2 equals 56.4 degrees. And that is my C2 acute angle. But we can see there's another configuration. So how do we figure out what that possible configuration is? Well, once again, let's use the law of sines to solve for this C1. Let's split that down the middle. And really, this is going to look a lot like where we started, the last angle, or the last triangle. The sine of C1 over 10 is equal to the sine of 30 over 6. Hopefully you're seeing like everything's the same. Like I'm not changing anything in this process, but somehow I'm supposed to come up with another angle other than 56.4. And while we need to consider really that like the back to our unit circle, the sine of some acute angle is going to be the same as the sine of the obtuse angle with the same reference angle. So if this is my angle theta, then the sine of 180 minus theta should be exactly the same. Another way of saying that is the sine of supplementary angles are equal. So what does that tell us? Well, if this 56.4 was the acute angle for C2, then C1 should equal, my obtuse angle should equal 180 minus that reference angle, 56.4 degrees. So that comes out to be C1 is 123.6 degrees. And you can check that. The sine of 123.6 is the same as the sine of 56.4. So in this case, we can make 2 triangles with this fixed angle side-side configuration. Case 2, we were only able to make 1 triangle. As you swung this side around, it only connected that ray in one place. So let's see what that looks like with our law of sines. Again, if this is our angle in question, the sine of C over 10, there's my angle on opposite side, is going to equal the sine of 30 over 5. Again, there's my angle in opposite side. So the sine of C is going to equal 10 sine 30 over 5. And I get the sine of C is going to equal, this comes out to be just 1. If sine of C equals 1, this is actually a special angle, so we should know this one. The angle C is going to equal 90 degrees. And that's actually, this is actually a right triangle in this case. So we could apply the same logic that we did before. If we said that the supplementary angles have the same sign, we could just check, like, so 180 minus 90 would be whatever the other angle is. But hopefully you can see here that this is the same angle, right? So this doesn't make two different types of triangles. It's just showing you the same triangle twice. So in this case, I can only make one triangle since there's only one sine value for this entire configuration of an angle, a side, and a side. So that can be the case too. You can make two triangles, or you can make one triangle. So that's it for this case. Sign 3, or rather case 3, you really can't make a triangle. There's no way I could swing this red point around all that I want, but it will never make contact with this ray as long as I'm at a 30-degree angle and I'm 10 units away. There's no way I can get that 3. I can pull it up to make that to reach that side. Can't be done. Let's verify that using the law of sines. So once again, if this did make an angle C, let's just pretend that there is an angle C. The sine of C over that opposite side, 10, should equal the sine of 30 over that opposite side, 3. So the sine of C is going to equal 10 sine of 30 over 3. And if you punch that into your calculator, the sine of C should equal 1.66, and then this goes on for a little while here. Now this should cause some red flags because I can't have a sine value that's over 1. Think about your sine graph. Sine goes up and down, up and down, up and down, and it only has a maximum of 1 and a minimum of -1. There's no range in your sine function that goes above 1 or below -1. If you took the inverse sine of 1.66 blah, 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 you'd get a domain error because you can't put 1.66 into your inverse sine function. What that means is no possible triangle. There's no way mathematically or visually, geometrically, that you can make a triangle of this. So here's a case where you have a fixed angle, a fixed side, but you can't make any triangle. So you could have 2, you could have 1, or you could have 0. Finally, case 4, we have one triangle again, but this we have to kind of check for our multiple cases, or rather see if we can't find a duplicate triangle as well. So let's see what that looks like. This one's a little bit different. Once again, here's my angle C, and let's go back to blue here. If I take the sine of C, divide that by its opposite side, 10, that should equal the sine of 30 over 12. And if I solve for sine of C, I get the sine of C equals 10 sine 30 over 12. And so the sine of C should equal 5/12. So I can take the inverse sine of both sides, so that the angle C should equal the inverse sine of 5/12. Once you punch that in your calculator, C comes out to be 24.6 degrees. So this is this is an angle for C, and that should be this angle right here. Now we need to check its supplement, because remember, all supplementary angles have the same sine value. So whatever the sine, this should the sine of this angle, the sine of 24.6 should equal the sine of its supplement, 180 minus 24.6. And it definitely does. If you were to type that into your calculator, whatever this angle is, it should equal the sine of 24.6. So let's just find what that other angle is. The other triangle would have that C1, or excuse me, the C angle to be whatever its supplement is, 180 minus 24.6. So that angle, in theory, could be 155.4 degrees. So the law of sines would still work out if this C was equal to 155.4. But there's got to be a problem with that. There's a reason why I wasn't able to make an obtuse angle out of the sine of this angle C. And let's think about that. I have an angle of 30 degrees, and the math is saying that I could also have an angle of 155 degrees. But remember, if I were to add just these two angles together, forget this angle. If I were to add this angle and then this angle, it should be less than 180. If I do that with this other possible triangle, I get an angle of 185.4, and right away this tells me this is not going to be a possible angle for this triangle. It breaks the triangle. It no longer is a triangle. The sum of my three angles needs to equal 180 degrees, and because I've already surpassed that with just two angles, this can't be a triangle. So we do need to check for the other possible triangle. It might not always be the case that the other triangle works. So we have these four different cases. We could have two triangles, one triangle, or zero triangles. And whenever you have one, you kind of have to test to see if you can create a second. So what do we learn from all of this? In summary, every single situation that uses the sine rule or law of sines where there are two sides and a non-included angle. So that is something like with what we had here, where you have an angle, you have a side, and you have a side. Or you could read this as side-side angle, or however you want to read it. It must be examined carefully. So it's not, you can't just say, oh, this, I know exactly what kind of triangle this makes. You have to be a little careful when you have this kind of configuration. And so that's kind of the four cases. On the next page, we're going to see some examples with this. So I'm going to stop the video here, and be sure to check out the next video to walk through how we can use this ambiguous case in practice.